All right, welcome to Chapter 4 Building Reference Datasets and Getting Started with Systematic Evaluation. So, last chapter we talked quite a bit about why building your own dataset is important, thinking about your own dimensions of quality, which are your metrics and rubrics, are important. Let's talk a bit about how to really do this in practice. And you do this in practice by building what you call as a reference data set, right? And this reference data set is essentially your first concrete representation of how the system should behave. And it's just a collection of realistic inputs paired with expected behaviors. And it's just a way for your team to sit together and identify what kind of queries might my system see, or what kind of input behavior might my AI system experience, and what kind of output behavior do I expect for that, right? And again, remember that we kept using this philosophy of input, expected, and actual. That's pretty much what a reference data set is. It's basically a bunch of examples with realistic inputs to them, expected behavior, as well as real behavior that your system is generating. Remember that in this course, we don't talk heavily about how to build AI systems that can achieve a particular outcome, because the emphasis of this course is evals. But we are assuming here that you have a system that you've built that could generate outcomes or actions that is required in order for us to build these evaluations. To build a reference data set, teams often try to build a very comprehensive coverage from day one. Right? They are like, let's get thousands of examples because we really need to understand and evaluate our system. Which is a good idea. Having more data is super useful, but generally it's also okay to start small and iterate on top of it instead of being overly obsessed with getting too much data on day one. Because as you start seeing how your AI systems behave, as you start understanding where they're going wrong, those observations can let you build more data instead of waiting for the absolute perfect set of data points that could evaluate your system, right? In AI systems, it's all about understanding behavior and iterating on top of that. So don't be obsessed about getting too many data points. Something like 50 samples is more than enough to get started. And to collect these 50 samples of input, expected behavior, and actual behavior, start with scenarios that you absolutely cannot get wrong in your product. Your product team and your SME should also know about this, which essentially are most of the times high risk situations where failure would be unacceptable. It can be common user flows that have to run smoothly, edge cases that would reveal important limitations. And the key takeaway here is all of them should give you highest amount of signal. There's no point of having 200 test cases that do not give you any signal. You just need 20 well-chosen examples that can show you different workflows in your AI system. This is a 6-step process that we recommend when you build your reference data set. Is to generate some initial examples, run your system through those examples, and evaluate with domain experts, right? And when we say evaluate, it means that evaluate what was good about this, and was there any issue with this response or with the outcome that we're imagining, and how can we get closer to a point where the outcome that we see is much closer to the expected outcome. You will start identifying some error patterns. You will start seeing that a particular set of patterns is being repeated with the examples that you generated. And that's what feeds into building the metrics that you need. Maybe you see that one of the common mistakes that your system is doing is to be overly verbose. Right? It's speaking too much, and that might not be good for your setup. And that's happening 2 or 3 different times. And that's where you probably need to think of, one, how do I fix this? Is there a way to fix this? You can play around with your system. You can probably have a prompt, etc. And if you see that the issue is recurring again, you probably need a metric in place, a verbosity metric that checks how often is your system getting way more verbose than required. And that's pretty much how you iterate and expand. You find an error pattern, you think about whether you can fix it with prompt change or any system change. If you're not able to fix it reliably, that's when you need a new metric which tracks this, so that you can find different ways or different patterns in which a particular system fails for that metric, and then keep trying to improve your system. That's essentially the 6-step process. This is an example in order to make you understand what we have said so far, which is, let's say, a customer support example. I've been using this example multiple times throughout this course just because it's much easier for everyone to understand this use case. Could bring up any niche use case, but then you'll be lost in the details of that use case. But everything that we're talking about for the customer support example could be translated to other domains as well. Now, let's say you build a data set for your customer support system, and it has something like the input is, I want to return my shoes, but I lost the receipt. Like this is a very realistic thing of how customers come up with. And the expected behavior is for the agent to ask for an order number, an email, explain alternatives, and maybe also generate a receipt, right? And there's probably someone saying your service is terrible and I'm switching. And here the idea is to acknowledge frustration, apologize, escalate to retention and stuff like that. So there are multiple of these different expected inputs that you can see. And you can also, once you start seeing these expected outputs and how your system is actually behaving, you can come up with whether the response is satisfactory and bucket them into different error categories. For instance, if someone says, service is terrible, I'm switching, and your system says something like, we're sorry you're leaving us, but thank you for letting me know, that's definitely an error that you want to flag and improve your system. And you realize that this is happening across 2 or 3 different examples, and this is also a red flag for you to identify and build more data in this domain, because it's turning out that your model is not performing very well. Then you say this is the error category, that escalation is not happening, or the tone of the agent was not correct, etc. And then you can come up with the potential cause, which is there's probably not a retention logic that's built into the system, and try to improve it. And then run your evaluation again to make sure your system is satisfactory at this point. So once you have this set of error patterns that you come up with, you can think of how to track these error patterns over time. There are 2 ways to track these error patterns. One is sometimes some mistakes that these agents make are very directly correlated with a particular issue in your system itself. Maybe you figure out that there's an error pattern because one of your tools is failing. Whenever the agent is trying to fetch customer information, it's not able to get that information because a tool or a function that exists for generating customer information is outdated or it's not working. You definitely don't need a metric for it, because you know the fact that if you fix that tool, then you can always get the right responses. So think of use cases or errors where a dimension or a metric must be used for tracking versus error patterns that can be fixed on spot and you can move ahead, right? Again, like I was saying, deciding which metrics you need, again, comes from this reference data set. If an issue can be fixed at once, fix it and move on. And don't need to build metrics that are useless and that can give you no signal in the future. If it can reappear in different forms, then you need an ongoing metric, right? And this is where a lot of teams think, I need 50 or 100 metrics, I need a dashboard of these metrics to continuously be looking at. Actually, it's counterintuitive, but you have to be more ruthless and create metrics for behaviors that you actually care about, and identify 2 to 4 key behaviors when you're building out your system, and then don't increase it until you've gotten more data. The idea is for you to maximize signal and minimize the cost that it takes to get the signal. Evaluating and generating metrics and all of this is an expensive process, so you want to be making sure that it gives you as much signal as possible. Some common pitfalls you want to avoid when you're trying to identify what are the right metrics that are needed. Don't make your data set too big too fast. Don't think that if the data is big, I might be able to get more insights and just artificially generate a bunch of it. Some people start with different permutations and combinations of the same kind of use cases just to show that they have a large data set, but it's kind of useless. For instance, let's say this example. If someone says, how do I track my order? I've seen people go through an LLM and synthetically generate, how do I track my order as to, can I see where my order is? Can I know when my order is arriving, and these kind of things. And if that new data point is not giving any new information and it's not helping you understand your system better, there's no need to have tons of examples. And that's also why we recommend not to heavily generate synthetic data initially. Have humans sit down and understand what different inputs might look like. You can definitely generate synthetic data once you get to 2-3 rounds of iteration, but initially don't do that. Never skip domain experts, especially when you're building workflows end to end. You want to be identifying how customers behave, what expected behaviors look like, and sometimes engineers are not the best people to tell you that. It is the domain experts who have all of this information, and make it easy for them to be part of the process. And don't overcomplicate rubrics. When you're building a metric, when you have rubrics, generally try to have rubrics like acceptable and non-acceptable. Don't have like 10-point Likert scale of 1, 2 means this and all of that, right? That will just confuse your AI system. You want to make it as simple as possible, just like you would do for a human. Make it as simple as possible to identify a particular metric. Key takeaways in this chapter is to start small. I've told this multiple times. Don't overpopulate your data set. Two is to collaborate with experts when you're doing this. When you build a reference data set, you want to make sure that experts also have brought in their unique perspectives. And always think of designing metrics for recurring risks. Think of metrics that you need to build so that you can consistently monitor how your system's performing. Don't overpopulate with multiple different metrics, right? Maybe tone is a metric that you care deeply about. Maybe helpfulness is a metric that you care deeply about, and you want to make sure that it's constantly being monitored. Don't add too many metrics, and every time you design a metric, it should come with a set of rubrics. What does good tone look like? What does acceptable tone look like? At the end of this process, you should have a reference data set that says this is the input, this is the expected behavior, this is the actual behavior of my system, and these are the metrics that I care about. And metrics are not just words, they refer to the entire set of rubrics that tells you what good looks like. That should be your deliverable at the end of this process of building a reference data set and identifying what metrics you care about. So now that you've said these are the metrics that I care about, and this is how my reference data set is looking, let's start talking about how to implement these metrics, how to put them into action. That's what our next chapter will be about.